Welcome to the Deep Dive.
Great to be here.
Today we're jumping into something pretty radical from the late 19th century. This idea of action at a distance, making machines move without any wires.
Yeah, it must have seemed like magic back then. Completely changed how people thought about, control.
Absolutely. So our mission today is to trace how this whole radio control thing got started. We're focusing on the first radio-controlled vehicles, specifically across 5 areas. Boats, planes, cars, helicopters, and even motorcycles.
And defining the first is, it's tricky, isn't it?
Right.
You've got the early proofs of concept, then maybe military prototypes, garage tinkerers, and eventually polished commercial products. It's layered.
So we'll try to pull out the key moments, the surprising facts.
And look at why they were doing it. The motivations were actually really different from a wild demo in New York to some very clever model engineering.
Okay, let's start where it really kicks off publicly. 1898, Nikola Tesla, the Telautomaton.
Ah, yes, Madison Square Garden. He had this small boat in a pond.
And it wasn't just moving, it was flashing lights answering questions. The audience was, baffled.
Completely baffled. They were seriously talking about mind control or maybe a borrowed mind inside the boat.
Incredible. But underneath the spectacle.
Pure engineering brilliance, really. It received radio signals using a device called a coherer, a simple radio-activated switch.
Okay.
But the clever part was a rotating mechanical switch inside the boat. Each radio pulse made it click to the next position, activating a different command, rudder left, rudder right, lights on, whatever.
So sequential control.
Exactly. But Tesla saw it as much more. He actually called it the first of a race of robots. He had this grand vision.
A philosophical vision, really.
Yeah.
Which makes the next step interesting because it came from a different place.
Yeah.
Spain, Leonardo Torres y Quevedo.
Right, Torres y Quevedo. His motivation was totally practical. Safety. He wanted to control dangerous things like dirigibles from afar.
So less spectacle, more function.
Definitely. His system, the Telekino, developed between about 1902 and 1906, was a significant jump.
How so?
Instead of Tesla's single type of pulse triggering sequential actions, Torres y Quevedo sent distinct digitally coded radio signals.
Ah, so like different commands for different functions.
Precisely. Independent control. He could manage up to 19 different actions without them interfering. It was true multi-channel command.
Wow. And he actually used it, right? Didn't he control a real boat?
He did. He demonstrated it controlling a launch, a full-size boat with 8 people aboard for the King of Spain. This wasn't just a model, it was a robust, practical system.
That sounds like the direct ancestor of, pretty much every RC system we use today.
It really is. Tesla lit the spark, you could say, but Torres y Quevedo built the more technologically advanced engine for practical remote control.
Okay, so we have boats, but then things take a turn towards the military, right?
They do. World War I changes the game. Suddenly, the idea of an unmanned aircraft isn't just curiosity, it's potentially a weapon.
Which brings us to Archibald Lowe in Britain.
Yes, Professor Lowe. His 1917 project, the aerial target, sounds harmless, but...
It wasn't a target, was it?
No, not really. It was designed as a pilotless, explosive-carrying aircraft. Basically, a guided missile to take down German Zeppelins.
And did it fly?
It did. On March 21st, 1917, they achieved the world's first successful radio-controlled flight of a powered drone aircraft. Lowe even used encoded transmissions to try and prevent jamming.
Thinking about electronic warfare even then.
Yeah.
Amazing. Now, the U.S. was working on something similar to the Hewitt-Sperry automatic airplane.
Right, but that was fundamentally different. It wasn't radio-controlled during flight. It was autonomous, pre-programmed using gyroscopes to fly a set course and distance, then dive. No human actively piloting it remotely once launched.
So an early split between true remote control and, pre-programmed autonomy.
Exactly, a distinction that still matters hugely today in unmanned systems. And this military tech eventually filtered down, leading to hobbyist RC planes like the Good Brothers Big Guff around 1938.
Okay, planes covered. What about cars? That seems like it should be simpler, but the history's a bit weird.
It is quite fragmented. The first big public splash was pure showmanship. 1925, New York City.
This was Houdina, right? Francis Houdina.
An electrical engineer. He had a Chandler sedan called the American Wonder driving through Manhattan traffic with no one inside.
Seriously?
Controlled wirelessly from another car following close behind, it turned corners, honked its horn. A massive publicity stunt.
But then nothing.
Yeah.
Kind of vanished for decades.
It did. That early stunt, while flashy, didn't have the miniaturized tech or the dedicated hobbyist scene needed to sustain it. Real RC cars as a hobby didn't really take off until the 1960s.
Driven by.
People adapting the smaller radio gear becoming available thanks to the RC airplane hobbyists. The first actual commercial RC car you could buy seems to be from an Italian company, Elettronica Giocattoli, in 1966. A little Ferrari 250 LM.
Right. Now, the really tough one, helicopters. The physics are just brutal on a small scale.
Absolutely daunting. This is where Dieter Schluter in Germany becomes central. He's often called the father of RC helicopters.
What did he figure out?
From the mid-60s onwards, he basically invented or perfected the key systems needed. Things like the swash plate mechanism to control the rotor blade pitch precisely, and stabilization systems like the Bell-Hiller mechanism to make the models inherently more stable and actually flyable. It was relentless work.
Trial and error, I imagine.
Lots of it, but it paid off. In 1970, he flew his Cobra model helicopter. That's regarded as the first fully controlled, successful flight of an RC helicopter.
And this wasn't military tech filtering down.
No, this was ground-up engineering by a dedicated hobbyist. He essentially created the field.
Amazing. Which leaves us with one more. The motorcycle. Why was that so late to the RC party?
Well, think about it. A two-wheeled vehicle needs active balance, right? It needs to lean into turns. How do you do that without a tiny rider making constant adjustments?
Yeah, tricky physics.
The breakthrough came from Kyosho, the Japanese company, in 1979 with their Elec rider.
And the solution wasn't electronics.
Not primarily. It was brilliant mechanics. They developed something called the Swing Differential Steering System, or SDSS.
Okay, what did that do?
It linked the steering input not just to the front wheel turning, but also to making the entire chassis lean into the turn, mimicking countersteering. That's what allowed it to bank realistically and stay stable. Pure mechanical ingenuity.
So looking back across all five, Tesla's big vision, Torzi Queveto's practical system, Lowe's military driver, Houdina's stunt, Schluter's hobbyist passion, Kyosho's mechanics. It's quite a mix.
It really is. And all these efforts, they directly laid the groundwork for, well, everything unmanned we see today. Drones, remote vehicles.
Torzi Queveto's multi-channel command is still the basis for modern RC, isn't it?
Absolutely. And Tesla's race of robots idea, we're kind of living in it now with automated factories and moves towards autonomous cars.
It's an incredible journey from that little boat blinking in a pond
to robots exploring Mars. The rate of progress is just staggering.
So maybe the thought to leave you, our listener, with is this. Looking at how we went from those first fragile steps to today's sophisticated systems, what does this history suggest about where automation and remote control might go next? What's the next frontier?